Hello and welcome to Rationals 2.2, Multiple Rational Expressions. Okay, so in today's video, I'm going to show you guys how to solve for x, just like the instructions say, except we have multiple fractions that we need to deal with. So the technique I'm going to show you guys is kind of similar to Rationals 2.1, where we made everybody have the same denominator, and because they all have the same denominator, they basically can cancel each other out. So that's the technique or the path that I'm going to work on. So let's show you guys how it works. So 2x, oops, how come it's not writing? Oh, there we go. Okay, a little funny though. Okay, 2x over 2x plus 3 minus 3 over 2x minus 3. So they have different denominators and equals 1. And I'm going to put that one as a fraction also. So put it as 1 over 1. Alright, so our goal is to make everybody have the same denominator. And the way to make that happen is basically just say to each fraction, what do you have and what do you need? So this first fraction says I have a 2x plus 3, so I need a 2x minus 3. So we say, sure, we'll give you a 2x minus 3. And you got to remember, if you give it to the bottom, you also need to give it to the top as well. Okay? And he doesn't really need the 1 because 1 times anything is going to stay the same. So I know he doesn't have a 1 visually, but he kind of does, right? Because the 1's not going to make a difference anyway. Okay? So the second fraction, he has a 2x minus 3, but he needs a 2x plus 3. So we're going to give top and bottom. Make sure you give top and bottom, yeah? If you just give it to the bottom, you're going to get some major stuff wrong. So don't forget to give top and bottom. Okay? And then the last fraction needs everything. Yeah, last fraction needs a 2x minus 3 and a 2x plus 3. And you got to put it on top and bottom, so that's a lot of stuff to write. Oops. 2x minus 3 and 2x plus 3. Okay, so I'm pretty sure we're all in agreement that everybody has the exact same denominator, right? They all have 2x plus 3, they all have 2x minus 3, and while these first two fractions on the left side don't have a 1, if I put a 1 there, it's not going to really make a difference anyway. So, yeah, we don't need to get the other two fractions to have the 1. Okay, but as promised, once I have everybody matching, I can cross out everybody's denominator. And all I'm left with is the tops of each fraction. So 2x times 2x minus 3. And then minus 3 times 2x plus 3, and then equals, and since I know the 1's not going to make a difference, I'm just going to write 2x minus 3 and 2x plus 3. Okay, oh, and before I forget, okay, this is where I like to usually, or actually I like to usually do this next step before I actually wrote down the numerators, everything that's left after I crossed everybody out, but I kind of forgot, so sorry about that. So you want to do what is called your domain restriction, and basically that involves figuring out what x value makes 0 on the bottom of each fraction. So if I plug in certain numbers in for x, they're going to create a 0. And if I create a 0 on the bottom of some of these fractions, the fractions are not going to like that, and therefore we have a restriction. Okay, so I'm going to basically do this. I'm going to solve for each x. Oops, I didn't want blue, I wanted purple. I thought I pushed purple though. Okay, I'm going to solve for each of these denominators. So 2x plus 3 equals 0, and 2x minus 3 equals 0. And when I solve for each of these x's, they're going to tell me what value of x creates 0 on the bottom. So we want to try to avoid that now, remember? So let's subtract 3 on both sides. So I get 2x equals negative 3. Then divide by 2, and I get x equals negative 3 over 2. So that's one of my restricted numbers that I don't want to ever come across or use, because if I try to use this number, it's going to create a 0 on the bottom, and that's going to be bad. So let's try to avoid that x value. Okay, so now let's solve for the other x. So add 3 both sides. Then we get 2x equals 3, then divide by 2, and we get x equals positive 3 over 2. So I want to also avoid that number at all costs, because if I try to use that number for x, I'm going to get a 0 on the bottom of the fraction, and game over. So let's avoid that, please. Okay, so let's continue on with the problem solving for x. So we're going to do some distribution here. Actually, distribution for the first two and foiling for the last one. So I'm going to get 4x squared minus 6x. And then this one's going to be minus 6x minus 9. Okay, so that's all my distribution. And on the right side, I'm going to do some foiling. So 2x and 2x will make 4x squared. And 2x and positive 3 will make positive 6x. And negative 3 and 2x make negative 6x, so they cancel out. And negative 3 and positive 3 make negative 9. Okay? Alright, so let's start to simplify these two sides. So left side becomes 4x squared minus 12x minus 9. And then that equals 4x squared. Actually, I don't think I said squared on the previous left side. So if I forgot to say the squared part, sorry about that. And your 6x minus 6x cancels out, and then you got your minus 9. Okay, so wow, there's going to be a lot of stuff that cancel out when I start solving for x now. So I know I talked about this back in one of the other lessons previously, but when you want to solve for x and you're dealing with a quadratic, you got to remember two things. At all costs, try to keep your x squared positive, and then make everybody on one side equal to 0. Okay, so when I start moving things around, what you're going to notice happens is a lot of stuff is actually going to just cancel out. So subtract 4x squared on both sides so that I can supposedly get everybody on one side equal to 0, but in essence they cancel each other out. And just like the negative 9s, they're also going to cancel each other out. And I'm not going to have very much left when all the dust settles. So let's see what happens now. So this cancels, this cancels, this cancels, and that cancels. So basically I have negative 12x equals 0. Okay, then I'm going to continue solving for x. So I'm going to divide both sides by negative 12. And I'm going to get x equals 0. Okay, so before I put that 0 in on the answer line and solidify this answer as a legit answer, I need to make sure the number I just solved for, which is x equals 0, is not a restricted number. Because if it's a restricted number, then I can't use that as a solution. So please remember that, yeah? Once you get your answer for x, don't just automatically put the number you just solved on this answer line. Make sure you check it with your restricted numbers, and if it's not one of my restricted numbers, you can safely submit it as one of your answers. Okay, but if it is a restricted number, then you're not allowed to use that number as an answer. Okay? Alright, so 0 is not a restricted number, so we're all good. First problem is all done. Alright, so let's go on to the second one. Okay, why isn't my pen working? It's not letting me push the arrow. Oh, there we go. Okay, so this problem, same like the previous one, right? We want to make everybody have the same denominator, and once I get everybody to match, then the whole denominator, the entire denominator is going to disappear basically. Okay, so actually I can do the main restriction right now. Actually, that'd probably be a better idea. Do it right off the bat so I don't ever forget it. So I'm going to look to see what kind of values of x make a 0 on the bottom of any fraction. Because if I make a 0 on the bottom of any fraction, game over. Okay? So I got an x plus 2 on the bottom of one fraction, so I set it equal to 0. I got an x minus 2 on the bottom of another fraction, so I set that equal to 0. And I have an x plus 2 and an x minus 2 on the bottom of the third fraction, but because I already am going to solve for the previous two, the x plus 2 and the x minus 2, I don't got to solve for the third fraction because I'm already kind of solving his pieces anyway. Okay, so let's see what kind of x's are going to cause my zeros to happen. Okay, my pen just went crazy again. Oh, there we go. Okay, sorry if I just draw these random lines, but it's because my pen is going to sleep, and because it's going to sleep, then it doesn't allow me to just continue writing. Okay, so I'm going to solve for x, so I subtract 2 on both sides. So for my first restricted number, I'm not allowed to use negative 2. And then for my second one, add 2 on both sides, so I get x equals 2. So my second restricted number is positive 2. So I better not use negative 2 or positive 2. as answers for x, because if I try to use them, game over. The problem is going to go crazy. Okay? Alright, so let's start my process of making all my denominators match. So first fraction, I got 2 over quantity x plus 2. And then second fraction, I got x over x minus 2. And in the third fraction, I have x squared plus 4 over x plus 2 and x minus 2. Okay, so I want to make everybody match. So this first guy needs x minus 2, so I want to make sure I put it on top and bottom. Oops, not a plus sign. I want to put x minus 2. And pen went crazy again. Oh, there we go. And then the second fraction needs x plus 2 to make him match with everybody else. And the third fraction, fortunately, doesn't need anything. Okay, so then since everybody's denominator is matching, I can cross out the entire denominator. So that kind of seems like a waste of time, right? We just figured out what they all match at, and then I'm just going to cross it out in the very next step. So it must be done, though. Yeah, it's not like we can avoid that step, right? Because getting rid of all these fractions makes the problem a lot nicer. So you kind of want that, right? Okay, so my pen keeps on turning off. I don't know why it does that. Oh well. That's a separate issue. Okay, so these are all my numerators. And let's see what happens when I start doing some math, like distribution. So let's distribute, and we're going to get 2x minus 4. Distribute again, so we're going to get x squared plus 2x, and then equals x squared plus 4. Okay, so let's clean up that left side. So I got x squared, and then 2x and 2x make 4x. Okay, come on, pen. Plus 4x, and then minus 4, and equals x squared plus 4. Okay, so just like the previous problem, we want to gather everybody on one side equal to 0, because this is a quadratic, and I'm trying to solve a quadratic, and for that to happen, you want to make sure x squared is positive, and you want to make sure everybody's on one side equal to 0. So let's move this x squared to the left side, and we're going to see that it cancels, just like the last time. It's not going to always happen this way, but sometimes it will, sometimes it won't. So don't just assume that it's going to cancel every time. Okay. And then what do we have left? So the x squareds cancel, and the 4x is still there, and we got minus 8, and then equals 0. Okay, so we're going to start solving for x. So we're going to add 8 on both sides, and then we are going to get 4x equals 8, and then we're going to divide by 4, and we're going to get x equals 2. So yay, we're done, right? We got our answer x equals 2, so we're going to put 2 on our line, right? Yeah, I hope you didn't do that. Well, I mean, I did it, but I did that on purpose, yeah? You're not supposed to submit 2 as an answer. You guys know why? Can anybody figure out why we're not supposed to submit 2 as an answer? Okay, and if you figured it out, hopefully you said because 2 is a restricted number, a number that we're not allowed to use. So, because 2 is a domain restriction type of number, then the only answer we came up with, which is 2, we're not allowed to use. So basically we have no, oops, it's not letting me write. Why does it always go to sleep, my pen? Okay, so no real solution is going to be your proper answer for this problem. Okay, and we're done. So I believe you guys have 4 problems that you're going to work on for homework. Good luck, and I will see you in class. Bye-bye.